Today I'm going to talk about Selenide. This is a library for writing UI tests in Java, browser tests. I am a developer. I guess most of you are also developers. And we will talk about, not about testing, but how we are developing software. Let's look what is the evolution of developer, as for me. The first phase of developer, the first stage of developer is developer who can write code. Whatever complex code you write, whatever complex technologies you use, whatever complex technologies you use, microservices, hyperservices, whatever, your big data, you are still on this phase until you can write clean code. So clean code that not only machines, but also people can read. The next phase is developer who can write unit tests, being sure that every piece of code actually works. And the next stage is developer who can write integration tests, being sure that the entire application works as expected. I guess most of developers probably do not write absolutely any tests, and some part of developers probably can write unit tests. It's quite separate, quite simple part. Probably many of us can it, but quite a few of developers can write integration tests or browser tests, UI tests, whatever, because developers typically think that this is complex. This is not easy. And I will show that actually nowadays it's much more easy, and actually nowadays we can do it, can write it. It's quite easy and fun. Let's look how the typical UI test can look like nowadays in our center. I am talking about UI tests for a web application. First of all, our UI test could open a browser window, and nowadays we can do it very simply with just command open. That's it. Next, we can find an element by name, by selector, whatever, by ID, xpath, and we can manipulate it. Can set value, type some text, click, select some options, and so on. And yeah, click. And in the end, we must verify that some state has been changed on the web page. For example, we can find some element and assert that it has some text or some value or some property and so on. So, isn't it simple? Quite unbelievably. Just 4 lines of code and some web application is a little bit tested already. It's pretty simple. So, can you write such tests? I believe you can. Nowadays you can. A few years ago, it was not that simple. A few years ago, you had to write pretty much of code. You had to run pretty complex, like Selenium grid servers and so on. And nowadays, it's just simple. I just mentioned once more that what is the difference between unit tests and UI tests or integration tests. In unit tests, you test a piece of code. So you must run method and verify that it returns some correct value. And there are plenty of technologies like JUnit and InUnit for this. And UI tests are almost the same, but a little bit higher level. So your test must open a browser, click buttons, fill texts, and so on, and verify that some text or some state of elements has been changed. Almost the same, but a little bit like complex. And we created a library, open source library, Selenide, for this type of testing, which is pretty simple. So Selenide is a free open source library that brings concise API and that helps you to make your tests stable. Because typically all integration tests or browser tests suffer from common problems, like you need to write a lot of boilerplate code, and your tests typically are unstable. They suffer from speed of Ajax. Sometimes Ajax is slower and like your test fails, and so on. Many times tests fail because of some timeout conditions and so on. In order to understand why a test failed, you need to research screenshots, and it's not easy. It was not easy until today. It was not easy until today. Now it's easy. Now this Selenide resolves all these problems, and now you can just start writing tests, and you can concentrate on business logic instead of bothering with browser details, Ajax, timeout problems, and so on. It's cool. Great news. Let's dive deeper. Welcome to the world of UI tests. How it looks like. There are several problems that Selenide resolves. First of all, Selenide can do smart weightings. What I mean, as I meant, problem number one for tests is like timeouts or timing conditions, racing conditions. So every shoot method of Selenide can wait a little bit. So if you write something like that, like some element should be visible, and typically most of tests fail because it was visible yesterday, but now it's not visible right now. Something has been changed on the server side, or Ajax has been changed to a little bit slower, and so on. To resolve this problem, Selenide can wait. This should be a method. It will check if element is visible right now, and if it's not yet visible, Selenide will wait for a few seconds. And you have plenty of different conditions that you can check. You can check that something is visible, something has required text, and so on. And even that something is not selected, is not visible, disappears after a few seconds, and so on. Plenty of checks. And once more, every one of these methods will wait as much as needed, but no longer than by default 4 seconds, and this timeout is, of course, configurable. For some slow applications, probably you need more. Error messages. We try to make error messaging like very readable. So it would be very easy to understand if test fails, why it failed. So, for example, if you write such a line in your test, like some element should not have text, for example, and if this test fails, Selenide will report like this text. This is very readable. It's very clear which element, what we expected, and what actually we got, and what was actually the text, and like all attributes of these elements. The next cool feature of Selenide is working with collections. I repeat, $1 finds the first matched element if there is many of them, and $2 returns like collection of elements, array of elements. And there is also plenty of conditions that you can check. You can check that collection contains so many elements, or you can check that collection contains expected texts, for example, and so on. Yeah, you can filter elements of collections. And probably you could see that Selenide suggests using chaining. You can put dot should be, dot should have, and dot filter, and so on. So you can chain methods a lot. It's quite usable for writing readable tests. The next cool feature of Selenide is automated screenshots. This is typical pain of quality engineers. They need to take screenshots, they need to store screenshots, analyze screenshots, and so on. With Selenide, it's pretty easy. Selenide just will take screenshot automatically on any exception. You do not need to do anything to enable it. It just works out of the box. So if you run test locally, it will take screenshot and put a link right here. It's already clickable. You can click and investigate why the test failed. And if you run tests on Screenshot or any other continuous integration server, this link will be like this. It will be clickable already on the server. It's pretty convenient to investigate why a test failed. And also, Selenide has plenty of helper methods. For example, for uploading file, you can easily upload files. It's not trivial with built-in Selenium functions. And you can also upload multiple files. And you can also download files. Oh, this is my favorite. This is my favorite. This is a typical script for downloading file in your test. You know, the script finds some link on the web page, tries to download it. As you see, it's pretty complex. This is what you had to write before Selenide existed. It's pretty complex. It tried to emulate user behavior, tries to emulate pressing Enter, space, Alt, S, and so on. It sleeps 2 seconds, once more, 2 seconds, and so on. It's pretty flaky and slow test. And I believe, yeah, if you can write such test, you must feel like Bruce Lee. This is pretty complex. And now with Selenide, you can just use one method. Just required element dot download. That's it. You have this file. Before we go next, probably I would like I would show some code, some live coding. Do you want to see live coding? Yeehaw! Okay. Let's test, for example, Google. Do you see well? Too small, like this. Let's try to enable in presentation mode. Let's try to test Google. It's the simplest test that I can imagine. Can you see it? Or so let's write a test. As you see, typical JUnit or test-ng or whatever test. User can search for any keyword, whatever. So first of all, we need to open a browser window. Easy. Static import. The next, we need to find an element with, probably you know, with the name Q. And we need to type a search keyword or type file into this. And we need to press enter. That's it. At this moment, the page should be refreshed. We can try it. OK. And in the end, we need to verify that some expected results are shown on the page. So we're using $2. We find a collection of elements, all expected results. They look like this one, IRS, like a smell of apple, you know, I results. And we need to verify, for example, that we have 10 of them. By default, Google shows 10 results. And we also can verify that first of them has text like probably good tests. Let's see what happens. So let's run. Will this test fail? Yeah, sure. Good test is not enough. Pretty tests. You see, it works. It just works. Pretty easy. Everybody can write such a test. Where is my code? OK, here it is. So, and let's look why the test failed. As I said, it writes quite a readable message that element should have text good tests, but actually it has text like this one. So let's fix the test. And as I mentioned, Selenide took screenshot automatically. This is a screenshot. We can browse it and investigate why it failed. Okay, so this is how it works. The next cool feature of Selenide is that it allows you creating extendable tests. I mean that you can, if Selenide doesn't contain some condition, some check, you can create new checks, new conditions. For example, if you happen to want to check that some element has some CSS property and Selenide doesn't contain this condition, you can create your own condition. It's typically very, very useful for creating your DSL, like domain-specific language for building your tests. Typically, QA engineers name it test framework, this DSL. So in order to create this like CSS check, you just need to create an instance of condition class and override method apply. Pretty easy. This is quite powerful mechanism for creating DSL. So the next thing, you can find elements by text. And so by text search for the entire text and with text search for the substring. And I personally think that this is a good idea to search elements. This is pretty opposite for the standard practices in testing. Typically, people prefer to find elements by XPath or CSS selectors and so on, but I personally like searching for text for elements by text because it actually emulates user behavior. Real users do not find button by ID. Real users actually find buttons by text or even more by color. Unfortunately, we cannot yet find elements by color, but by text it's possible. The next thing that is very convenient in tests is searching parents and children of elements. For example, the method someElement.parent looks for its parent, closest looks for its some grandparent, and find looks for child. So very useful to navigate between elements. You can also use sizzle selectors in Selenide, as you see. This is pretty powerful mechanism for like searching for inputs and so on, for first element and last element and so on. And also Selenide contains a built-in profiler. When you have a lot of tests, when you run them periodically, you pretty quickly run into the problem that you have too lot of tests and they take too lot of time. And this is the moment when the profiler comes into the game. Profiler will show what are the slowest parts of a test or what actions take the most of time in your tests. So Selenide just has built-in profiler. You can use it. And of course, Selenide contains much more functions that I'm not going to describe. There is just too many of them. You can scroll to any elements. You can use their text or HTML, or you can check if something is image and so on. You can emulate movements of mouse and so on, and many more. But the good part of it is that you do not need to remember all this stuff. The only thing that I ask you to remember about Selenide is that you do not need to remember anything. Because, do not need to remember, do not need to read a lot of documentation, because we designed Selenide so that it would be easy to use from IDE, Integrated Development Environment. So you just start typing. This is thing that I personally like. You just put dot and start typing. And good environment will suggest you all possible options. This is that I demonstrated here. So who knows how to put it? Okay. it disappeared. Okay, so you put dot and just look for all possible options. You do not need to remember anything. Pretty convenient for writing tests. This is what I name good software. I like to say that poor software does not have documentation. I'm often asked with this question: does Selenide have a lot of documentation? And I like to answer that poor software doesn't have documentation, but brilliant software does not need documentation. This, of course, doesn't mean that Selenide doesn't have documentation, but it actually doesn't need documentation a lot. I will show. Okay, I will show one more example. Example of running Gmail tests, like of running tests that tests Gmail, like checking inbox and creating new mail. It's typically a very hard problem to write tests for Gmail because I don't understand. Okay, let's close Gmail. Okay, I will show you another example of running tests for one real internet bank. And before we start, it starts a real application right now. It starts a real internet bank, as you see. This is one of main points that I wanted to show, that good tests should not depend on any installation, on any external server or installation. The good test should initiate application itself, in test configuration. Should prepare all the initial data for the application, all the initial state of all services, like of all parts, and then should start clicking. This is what now happens. The test have started the application, have prepared the initial database, and now it will click buttons. And as you see, I can start tests on my machine. And I can start a real internet bank in test configuration on my machine. This is test configuration, yeah? This is like a test setup, some few artificial accounts and so on. Yeah, so how it looks like. This is absolutely real example of my everyday work. We do develop internet bank and do create automated tests for it. Okay, and let it run. So finally, some best practices, our best practices. In many companies, the process of developing and testing is pretty ineffective. What I mean, developers, when they do some changes, they cannot right now check that these changes are good, that nothing is broken. They send an email for administrators, for system administrators, asking to install the updates to some test server. Administrators install these updates to test server, like test your company and probably if you have some continuous integration server, typically in most companies, automated tests run against this server. And when they run, the test report comes to testers, quality engineers, who need to analyze the results of these tests, and they send feedback to the developers. So this is very, very long chain. I believe that tests must give quick feedback. This is a main point of tests. Tests must help developers to quickly get feedback if everything works or not. This is too long chain, and that's why this is ineffective process. Effective process should look like this one. Developer, when made some changes, should be able to run tests locally on his machine, be sure that everything still works, and only then can commit changes. Some continuous integration server can run tests again on localhost on the same server without requiring any installation, without requiring any manual work of administrators or whoever. And only then administrators can install these changes on some test server. And only then QA engineers can analyze if everything works. In this case, they get almost working like software. And developers are not afraid of committing changes because they can always test locally if everything works. So rule of thumb for me, our best practice is that developers should be able to run tests before commit, meaning locally on their machine. This doesn't mean that they will run tests every time, because sometimes it takes time. But it should be able to do if they want to be sure if everything works. In other words, your project should always have two commands. Gradle, something like Gradle test for running unit tests from command line, and like Gradle UI test for running browser tests or any other UI test. Right now, right on my machine from command line. This should be able to have a really efficient development process. I can demonstrate this. For example, this is absolutely real working project. I can type play unit tests, and it will run unit tests, all unit tests of this internet bank. As you see, it will compile all the code, and like with one click, and run all the tests. This should be easy, like this. How to enable it? How to make it possible? This is up to you, but typically the best practice is that your application must have test configuration. You can run a real internet bank with real money, and you can run test internet bank, absolutely the same code base, but in test configuration that uses some mocked data or some predefined data set, some like few artificial accounts and so on. And you must be able to run your application on localhost, I mean on your machine, without need of manual installation for some administrators. You can use JT, you can use embedded Tomcat, whatever. You can run whatever for this, but do it. The next best practices for us is using in-memory database. It's not pretty good for using in production, I guess, but in tests it's ideal. You can run in-memory database without need for manually set up anything, for install Oracle or anything else. And in-memory database allows you very easy preparing some data set for testing. And you can very easily reset database state before every test. It's very quick and easy. For example, H2, our favorite in-memory database, but you can use anything else. And of course, this is must. You must mock external services. Your tests must not depend on any external system, like sending SMS or anything else. For example, one technology that allows it is WireMock. This is open source library allowing you very easily to mock any HTTP REST services. So it's up to you. You are smart. Use whatever technology to make testing easy. Thank you for the attention. Make the world better by writing automated tests. I believe that world will be better when all of us will start writing automated tests. Thank you. What about questions? I don't know. Yeah, please. Sorry? What browsers Selenide supports? Actually, all browsers. All browsers that Selenium supports. Chrome, Firefox, Phantom.js, HTML unit. Yeah. We have some problems with Safari. It's officially supported, but doesn't work. Yeah, one question? Is it possible to test Angular application? Yes, it's possible. Why not? But probably, I don't know, probably Angular has its own testing framework. Probably it's better, I'm not sure. But yes, technically it's possible, to test whatever. I don't see, yeah? Sorry? Yes, if application opens a second window or second frame, whatever, yes, it's all supported, sure. No problems. So please feel free to ask more questions from me here. Thank you for your attention.